This video goes with the box plot example. I'm just going to do it by hand instead of using on the calculator. I'm not going to do everything by hand, but I just want to show how to do these by hand. So you should watch that video first. This is the population growth data. I'm just going to do it for the more interesting case, the more interesting example, which is the right-hand side, the southern and western states. So to do the, oops, that's not going to work. To get the box plot, first we need to figure out the 5-number summary. In particular, we need the median, the Q1, and the Q3. Okay, so we've got our data sorted here. That's not too bad. So what's our N? We've got to count how many data points we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. Okay, so we're going to go start from here, and we're going to look for the 15th data point to be the median. So, because if it's the 15th, there's going to be 14 higher and 14 lower. When it's an odd number, it's always this divided by 2 and then plus a half. Okay, so we're going to look at this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I was careful to count down on that one. And so that's 15, and that's what the calculator told us. Okay. And then the Q1 and Q3, okay. So there's 29 of these guys. So there's 14, and then the median, and then 14. And so we want to divide up, we could really say this is 15 together. So we're going to count down from the top and go to the 8th one from the top and the 8th one from the bottom. Okay. And there's issues a little bit about exactly how to do that, but they're never super important. So I'm going to do the 8th from the top and the 8th from the bottom. And that may or may not exactly agree with how the calculator did it. So 1, 2, 3, 4, 5, 6, 7, 8. So 23. That's the upper side. That's Q3. And then 1, 2, 3, 4, 5, 6, 7, 8. And that's 11. Okay. If you recall, they actually they had some 0.5s here. So they had 10.5 and 23.5. So I'm not too concerned about exactly how that works, but we can use either of these for the summaries. Okay. So what's the IQR? Okay. It's either 12 or 13, depending on exactly how you do it. Okay. Let's go with 12, just to take this method. Okay. And then what are we supposed to do with the box? We're almost ready to start creating the box plot. Okay. And so I need the whole range. We know, the min was equal to 1. Strange state for the northeast or the southern west that only was 1 growth rate. And the max, of course, is 66. So that requires us, let's go up to 70 there, 35, 0. Okay. And so we can draw the box. So let's see, this 15 is going to be about there, and 11 and 23, so about 10, 25. I'm doing it very vaguely. We probably want to do graph paper, but I just want to give you the idea. Okay, so 11 to 23 is the box, median at 15. Okay, and then we have to figure out where our fences are, the way the book talks about it. We look at the IQR, 1.5 times the IQR. If we use the 12 there, it's about 18. So anything that's 18 more than this is going to be an outlier. So 41 would be where the outliers start. Notice that this is close to being an outlier by that definition, but not quite. It's going to be just a really long whisker. Okay, so we can draw the whisker up to like 40, and that's going to be the Arizona data, as it turns out. And then certainly down here, there's nothing that's going to be less than -7 or something like that. So we're going to draw the whisker all the way down to just almost touching to 1. Okay. And so there's that 1 above 23 plus 18 where the fence is. Remember, they say don't even draw the fence, but it would be right here at 41. Anything above that is considered an outlier, and that's where this 66 is, up here. Okay, and that's not Arizona. That was Nevada. Basically Las Vegas, or mostly Las Vegas, maybe Reno too. Nevada, that turns out to be Arizona, and we don't have identifications for the other part of the data. Okay, so that's the box plot by hand. And again, probably if we had been a little careful, we maybe would agree with the calculator values, but you can see there's not a big difference there. So that's how to do that by hand. What about the other part of like the 1-var stats? The mean is going to be the sum. Remember, this sigma is just means sum. It's not a particularly scary kind of concept. It's just the sum of all of the x values and then divided by n. So we know that's going to be divided by 29. Okay. And let me just go ahead and do it. We wouldn't do that literally by hand. We'd use a calculator in some way, even if we didn't want to use the 1-var stats. But let's actually just do it right here. I don't know if I can't really do this on one screen. Actually, I'll write it down here. It'll be just as easy. Okay, so we're going to take 66 plus 40 plus 31 plus 30 plus 30 plus 26 plus 20 plus 20 plus 21 plus 21 plus 23 plus 24. You get the idea. I'm not even going to write it out. Okay, all the way plus 1. And then we're going to divide it by 29. Okay, and we'll trust the calculator, if you remember from the other video, it's like 18.86. Okay, just we know how to do this. The mean is just the average of a bunch of numbers. We all know how to do that. The more interesting thing is the standard deviation. And again, I'm not going to write out the whole calculation because this is exactly where computers and calculators are very useful. The standard deviation, S, for various interesting but pretty technical reasons, we divide by 28 by n minus 1. Okay. Well, actually, this is going to be the variance, S squared. We first do that. And then what we do is we take the sum of the deviation, the squared deviations. So what we would do is we'd take, for example, this 66. We'd say take 66 minus 18.86. That's a deviation. That's one of these guys. And that's going to be 41.14. And then we're going to square it. And that's going to be one of these guys that we're going to sum up. Okay, so that's going to be one of these numbers that we're going to square. 1 squared deviation. And then we're going to take another one. We're going to take Arizona, 40 minus 18.86 squared. Oh, don't square it yet. That's going to be like 20. Oh, that wasn't 41.14. That's 47. Yeah, I don't know why I said 41. This is going to be 21.14. Okay, and then we're going to square that. And we're going to take all these numbers, the squared deviations, and then sum them up, and then divide by 28. We're still not done, though. That's called the variance. And then we're going to take the square root of that to get the standard deviation. May seem like a lot of work, especially compared to just calculating the IQR, and especially when this was an example where that number was actually not a particularly good measure of spread. But we're going to see in later chapters how, especially for like the normal model, which is a hugely important thing in statistics, this is a really, really well-behaved measure of spread. It's a lot of good properties. The thing I just want to say right now is why would this make any sense? Well, look at this number. For example, 66, it's really far from the mean. You get a big number here. Now, this number could have been positive or negative. And one reason we're taking the square, definitely not the only reason, but one reason we're taking the square is to make sure we get a positive number. so that these, when we sum them up, they don't actually cancel out. We don't want things far above and far below the mean to cancel out. We want them to both contribute to a measure of spread. So we square them, we add them together, and roughly take an average. And then there's this very technical issue why you divide by n minus 1 instead of over n. But it is giving a measure of, on average, how far things are from the mean. And then you take the square root, because these guys actually, when you square them, you get the wrong units. And the square root, it basically preserves the units, right? So this is definitely something that's a tease for later stuff that we're going to understand more later on. But I wanted to make sure that you had some idea of that this is really a fairly straightforward calculation, just kind of tedious. And we're letting the calculator do it just because it's tedious, not because it's super weird.